Alright, so I just did a video on the area of a triangle, and there's my triangle with side versus A, B, C, opposite side A, B, and C. And we said that these were the areas. And so since these are the areas of the triangle, I can safely say that 1/2 AB sine C is equal to 1/2 AC sine B, which equals 1/2 BC sine A. And here's the neat thing about it. If I multiply everything by 2, all right, I'm going to multiply each of these terms by 2. I'm left with AB sine C equals AC sine B, which equals BC sine A. And now I'm going to do something else that's very clever. I'm going to divide each of these terms, because they're all equivalent, by ABC. And this is wild stuff. This is really, really good. Check this out. Ready? The A and the B will cancel out here, and then I'm left with sine of C over C equals, here, I get rid of the C's, and look what I'm left with, sine B over B, and here I cancel out the B's, C, and I'm left with sine A over A. Oddly enough, when I teach this, I usually don't teach it that way. I usually teach it as this, A over sine A equals B over sine B equals C over sine B or sine C. It doesn't really make a difference. And now here's how it works. I'm going to show you a little trick which I think is super, super useful. Let's say I have a triangle. Well, as a matter of fact, I do have a triangle. And I'm going to put in some values. And let's say the values I put in are, I don't want to use values that aren't going to work, but let's say I put in C is 67, little b is 56.3, little c is 80.2, and I want to find angle B, so that's theta. So what I like to do is this. I usually say A, B, and C, A, B, and C, and I plug in, and you'll see why this is useful in the next video as well. We say little a, I don't know, and big A, I don't know. Don't really care about either of them. B is theta, and this is 56.3. And this is 67 degrees, and this is 80.2. I like to do this because it helps me keep things organized. And I always say, if you can draw a box around them, then you're in great shape. Then you can use a lot of signs. So I'm going to say B over sine B equals C over sine C. And it ends up being 56.3 over the sine of theta equals 80.2 over the sine of 67. And now I'm going to cross multiply, and you get 80.2 sine theta, which equals 56.3 sine of 67. And then I'll divide by 80.2. And so what I end up with is sine of theta is approximately, and what I like to do is I like to do it all at once. I say 56.3 sine of 67, and I get my answer on my calculator, which is 51.82442325. And I just divide that whole number by 80.2. And I get approximately 0.646189816. Now, I'm not actually going to find that out, but what I am going to do is I'm going to use the sine inverse function. and I'm going to use the answer function on my calculator, and that will give me an answer of 40.25 degrees. One of the things I want you to realize is once you find out that B is 40.25 degrees, you know you can find out what A is real quickly because it's a triangle. So the angles must add to 180. And so 67 plus 40.25 gives me 107.25. And, oops. And so A would have to be 72.75 degrees. And I found that by adding up this value and then subtract from 180. Now you could find the third side by using the law of sines. A little piece of advice, I would use this one and then that, just in case you made a mistake on B. Well, I guess you made a mistake on B, you're going to make a mistake on A. That doesn't matter. In any event, watch my next video on law of cosines because that's going to be a good one. I hope this was useful. And, well, one last thing. We found the angle, but it's also very possible to find the missing side using the law of sines as well.